Howdy folks, Mr. Reed here, and welcome to One More Question. So what I'm going to be taking a look at right now is just some kind of random angle terminology. I'm going to be going over some trigonometry topics in the next little bit, most of which require us to take a look at angles as represented on the Cartesian plane, so your normal XY coordinate system. So there's some terminology that kind of goes into effect to help us to discuss this stuff properly. So I'm going to call this one a medium level video, and it's just going to be an explanation of some terms and notation. So if you want to get started on some trig, you're in the right place. Let's get to it. All right, now there's not really a question up above because of what it is I said that I'm covering. Oh, and the other thing is I'm kind of messing around with my audio setup a little bit. So if you notice something particularly bad or annoying about what's going on with it, if you could either leave me a comment down below or send me a message, that would be great. All right, so first things first. What are we talking about when we are saying we're going to be representing angles on the Cartesian plane? So let's make a little Cartesian plane here. And so we'll say that this is the y-axis, this is the x-axis. Now, we actually have a way of representing angles that's considered to be a standard method for representing these things on the Cartesian plane. So if we are to do that, the first of the two arms or rays of the angle lies along the positive side of the x-axis. So we're always going to center or put the vertex of our angle directly on the origin. And so in standard position, so I probably should write that down. So standard position, we are going to make it so that the initial arm, so the first one, goes right along that positive x-axis, and then the terminal arm, which is the second one, is going to be considered to be a rotation away from that. If the rotation is in this direction, which is counterclockwise rotations are positive. If we were to go the other way, so wrap around in this direction, that's a clockwise rotation, and clockwise rotations are going to be considered positive instead. So, or sorry, negative. My apologies. I was thrown off by the fact that I was writing a positive there in the first place. So, with this particular angle, this is in standard position, and we can talk about positive or negative rotations of that angle. A lot of times, I'm going to be using a theta, which is this little Greek letter, to denote an angle that I don't know the measurement of, or I just want to define a way to refer to that thing. Theta is very frequently used with angles, kind of like x becomes a bit of a default with your typical unknown in a linear, quadratic, or other type of algebraic equation. Once you have something that you know the answer is an angle to, you can still use x, but it is pretty common to see this theta come into play there as well as a bunch of other Greek symbols sometimes for angles too. So like phi, alpha, beta. You can kind of bump into those as you do more work with angles. All right, so when we're talking about this angle theta, most people, if you're watching this video, are probably aware of measuring angles in degrees. So degree measurements, 90 degrees is your nice right angle. 180 degrees is a semicircle, I guess. It's just a flat angle if you wish. And then 360 would be all the way around. And you probably know some other, or have a concept of some of the other special angles, like 45 being halfway in between 0 and 90. You might have a good idea of where 30 and 60 lie too. The thing is that degrees, while very, very convenient because of the fact that 360 can be divided into has many nice whole number divisors. So 2 goes in, 3 goes in, 4 goes in, 5 goes in, 6 goes in, 8 goes in, 9 goes in, 10 goes in, 12 goes in. I might have missed one, but anyway, and 15 goes in. There are a lot of different nice whole number divisors. And what that means is we can split a circle up into 8, 9, 10 different pieces, and each one of those pieces has a very, very tidy number for the degree measurement of that little piece that's left, which is really great. Radians is also another angle measurement that's really, really popular, especially amongst people that are doing some math, because they actually they are unitless, which I don't think I'm going to cover in this video, but for the time being, I'm just going to say that we're going to define one full rotation to be 360 degrees, and for radians, it would be 2 pi, and then I'm just going to put radians down here for that same full rotation. So if we want to go around once, 2 pi, sometimes the pi throws people off because they think of it as being something that's not just a number. That's exactly what it is. It's just a number. So 2 pi is the same thing as, say, like 5 or 8. It's just a numeric value. But because we use the Greek letter pi in there, a lot of people feel that that's not necessarily the case. It is, though. So 2 pi, just a nice normal number. It's a number, though, that relates very, very closely to the idea of how a radius and a circumference in a circle would be related. Because of that, it tends to be very, very useful from a math point of view. So if you ever have, for instance, an angle that's measured in degrees, we could say, well, if I have a 45-degree angle, that is a particular ratio of one full rotation, which would be 360 degrees. If I were instead to take a look at that same angle, but it's measured in radians instead, it would be that many radians out of 2 pi full rotation in radians. So what we can do is basically just use ratios in order to determine what the measurement would be in radians. So 45 is going to be, if we reduce that 45 over 360, that's 1/8 of the entire rotation, or the entire circle. So if you're thinking about this as being so 0 and then 90, I gotta remember, I'm doing things weird. I think it's this way. So 0, 90, 180, 270, 360. So if we were to basically do that idea of a full rotation there, then 45 degrees is half of one of those quadrants. So 4 different 90-degree rotations, it would be 8 of the 45-degree rotations. So we get this idea of 1/8 here. Now, we could say that that's equal to theta over 2 pi still. Multiply my 2 pi up onto the other side, and then we could reduce it from there. But I'll take the one more step in order to do that. So we'll divide by 2 top and bottom and get pi over 4 is equal to that angle. I'm going to do a video at some point in time, I don't know if it will be next, on talking about the unit circle. And when we do the unit circle, you're going to see that there are these nice fraction measurements in radians that kind of go along with the very common angles that we might want to bump into. This pi over 4 is one of them. You're going to see many more if you are to work more and more with this idea of radians. So just for the time being, it might look a little weird, but you'll want to put some effort into memorizing some of the ones that come up more commonly, so that you can recognize what it is that you're talking about and be able to orient yourself in terms of Cartesian plane where you end up being. Now, the one other thing that I think I want to discuss right now is the idea that angles can be more than one full rotation, and then they can be positive and they can be negative, which in the end leads us to this idea of, if you have an initial arm and a terminal arm, that is not enough to kind of determine what the angle is. So we could label this angle, for instance, this way, and maybe it ends up being 120 degrees. We could go around this way, and it could be negative. We could get a little fancy, and we could go around one full time and then back around to that little spot. And that would be 360 for the first rotation, plus another 120 degrees for a total of 480 degrees. All 3 of these angle measurements that I have so far are what we call coterminal angles. So coterminal meaning they end with the same terminal arm. They share a terminal arm. So how many angles would be coterminal with each other? Well, an infinite amount. If you have some sort of domain restriction where you're not allowing certain rotations, then it's going to be, of course, confined to some value. I guess if you have it double blocked off, so if your domain is limited on both sides of some values, then it's going to be a limited domain where you only have a certain number of answers in the middle of it. I guess if you went from, for instance, 0 but allowed any positive rotations, it would also be infinite. So it's only if it's basically the idea of being blocked off on both sides. So if an angle is coterminal, it shares a terminal arm. And that idea of having something that's coterminal is really important, because once we start solving equations, we'll recognize that if you have some sort of trig ratio and it's equal to a certain number, it's not just one angle that would cause that ratio to show up. It's an infinite number of angles if you allow the entire domain. So it becomes very important to be able to write down what coterminal angles are. So in this case, for instance, if I had 120 degrees and I said, how can I list all coterminal angles in degrees of this 120? Well, let's call that theta. And I'm going to say that we're going to tack on full rotations. So every full rotation is going to be a multiple of 360 degrees. Whether that be a positive full rotation or a negative full rotation, they all depend on this 360 degrees to be happening. Now, I put k in there, and I want k to represent only full rotations, positive or negative. So what I really mean is I'm wanting my k to only be a part of the integer number system. So what I've written here, if you're not used to it, is that's a defined rule for k. K is an element of the integer number system. So I use a little blackboard bold Z when I'm doing it by hand. It doesn't really matter. Some people use an I for integers. Some people would just do a normal plain old Z, and that would be acceptable there too. So I think for now, that's probably a pretty good start. So we know what a standard position angle is. We know what positive rotations are. We know what negative rotations are. We know that angles can be measured in degrees, but they can also be measured in radians. And if we want to start to move between the two, we could always set up a ratio. So however many degrees out of the full rotation is equal to however many radians out of the full rotation. And you're going to know one of those two quantities, and you can always solve for the other one after you set it up. We know what coterminal angles are, and we understand that there is a way to write down the full set of coterminal angles if we need them. That should be able to give us a bit of a start into picking apart some trigonometry stuff. So hopefully you found that one helpful. Like, subscribe, and as always, take care, folks.